All right, hi. We're going to be working on the 2021 Math MCAS. This is number 27. This is in the calculator section, so you're going to want to use a calculator in this. This is a four-parter, so this might be a longer video. Let's check this out. This question has four parts. The types and colors of the vehicles for sale at a dealership are shown in this table. This table right here. Part A, based on the table, what percentage of the vehicles for sale at the dealership are trucks? Show or explain how you got that answer. Okay. So we're looking for a percentage. Okay, let me zoom in here a little bit. So what percentage of the vehicles are trucks? So we're going to have trucks over total vehicles, and we're going to multiply that number by 100, and that'll tell us. So total number of trucks are 189, and the total number of vehicles is 420. And we're going to multiply that by 100. So 189 divided by 420 is 0.45. So times 100 would be 45%. What fraction of the vans for sale at the dealership are blue? Show or explain how you got your answer. All right, so again, same thing. We're going to look at what fraction of the vans for sale are blue. So vans are going to be on the bottom. And this is a fraction, it's not a percentage. So vans are going to be on the bottom, and the blue vans up top. So blue vans are going to be, let's see, 127. Total vans are 200. Total vans is 231. So 127 over 231. That's it. Let's look at part C. All right, part C. What fraction of the vehicles for sale at the dealership are red or are vans? Okay, so, all right, well, let's think about this. Vehicles for sale at the dealership, so it's a fraction. So the bottom's will be 420, so that's the bottom, all the vehicles. Total vehicles. And then red or vans. All right, so red vehicles are 115. And then we have to add, sorry, I should do this here. So 150, so there's red vehicles here. I should probably put auto lock on. Here we go. So that's how many red vehicles there are. So we're going to have that here, 115. And then we're going to also include the other vans. However, we already have red vans here, so we don't want to double count that. So we're going to add the 127 to represent the blue vans and 51 for the green vans. So it'll be 115 plus 127 plus 51 over the total number of vehicles, which is 420. And we just have to add the top and leave it as a fraction. So let's do that. And again, we would have access to a calculator for this. So 115 plus 127 plus, should be 51 there. That should equal 293 over 420. And that's the fraction. Okay, last part. How many of the vehicles for sale at the dealership are vans and are either red or green? Okay, so again, we're doing a fraction. And are we doing? No, we're not doing a fraction. Sorry, never mind. How many of the vehicles? So this is not going to be a fraction. So are vans and are red or green. So we're looking for red or green vans. So red or green vans. So so red is 53. 51 is the green. So 53 plus 51. That's weird. 104 vehicles. Okay. Make sure I'm reading that correctly. I think I am. Yeah, there we go. All right, so that's number 27. Isn't so bad. All right, number 28. All right, 28. Two students calculated the area of a circular skidding rink that has a radius of 20 yards. The first student calculated the area using 3 as an estimate for pi. The second student calculated the area using 3 and 1400ths, or 3.14, as an estimate for pi. Compare the students' calculations, select from the drop-down menus. So what I'm going to do is actually, I'm going to pause this. I'm going to write down the options that are available in the digital version. 1 second. Okay, so I wrote down the options that are available, first, second, and then 3, 8, 14, 56. So we should be able to select the correct option for the first one without really doing any estimates, any real math here, because we know that pi is closer to 3.14 than just 3. So the second person is going to be more accurate already. We know that. So let's circle second. And we have to choose how much roughly they'd be accurate by. So the best way to do that, I think, would be to calculate the area of a circle using both these versions and see the difference between the two. So the area of a circle formula is going to be a equals pi r squared. Okay, and we're going to leave the radius as 20. Okay, so a equals pi, and we'll do the first. This will be the first student here. Zoom in a little bit here. So pi for the first student will be 3, and then 20 squared for the radius. So 3 times 400, and that means 1200. And this will be a for the first. Yards, square yards. Okay, so that's the first one. Let's try the second student. So a equals 3.14 times 20 squared. So a equals 3.14 times 400. And this is where I'd want to use a calculator because I don't feel like writing that all out. And 4 times 400, 1256 yards squared. So it's more accurate by 56, which is our last option, because we know this is more accurate. And that's it. So this problem is asking us, first of all, do we know the area formula? This would be on the, this is on the reference sheet when you click on the button on the digital version. But yeah, you have to be able to basically do it twice. And you have to understand that this is closer to pi than this is. And that the difference between the two values would be how much more accurate the second one is. So I could see that one confusing folks. All right, 29. Okay, so number 29. A triangle and some of its measurements are shown here. Based on the diagram, what is the value of P? Okay. Well, first of all, we know this is a 90-degree this is a right triangle. This is 30, which means this is 60, which means this is a 30, 60, 90. Okay, if we go back to our reference sheet, let's see here. Yeah, this is, yeah. So here we go. So, excuse me. So the side opposite the 30 degrees would be X, or I would actually just cross P out for a second. And I'll show you why. The reference sheet on the test doesn't have as Y. I don't know why I always put it as X. It doesn't really matter. It's a variable. I'm going to put X. X, 2X, and X radical 3. But it could be any variable. So it's asking for the value of P. So it's going to be X times radical 3. So it's 15 times radical 3, which is right here. So if you know it's a 30, 60, 90, this problem, in my opinion, becomes very, very easy. But you have to know you need to know it's a 30, 60, 90. I guess you could use trigonometry if you really wanted to, because you could say cosine of 30 is 15. No, sorry, tangent. You could say tangent of 30 would be 15 over x, and solve for x. You could do that too. But it's way faster doing it this way. All right, cool. Number 29. So 30. Number 30. Okay. Match each geometric term with its definition, drag and drop each definition under the appropriate box. So in the digital version, you just click on it and drag. Okay. The set of all points equidistant from a point in a plane, that would be circle. Lines in a plane that do not intersect, that would be parallel. They're specific to say in a plane because otherwise it could be skew. Two rays that have the same endpoint, that's going to be angle. And then part of a line that contains two endpoints and all the points between them, that would be a line segment. This one's pretty straightforward. Number 31. Oh, I forgot about this one. All right, this is a good one. Triangle TUV is shown on the coordinate plane. Here's TUV. Triangle TUV will be reflected over the x-axis. The image of TUV will be then translated 2 up and 1 left. What will the coordinates of the final image of V be? So we're looking for V double prime. I really don't like where they don't use the proper notation here. All right, so T prime is going to be a flip. Sorry, V prime will be a flip, and then V double prime will be a shift. So let's just do to V what they're describing here, okay? So V's here. They're going to reflect over the x-axis, so V would go 1, 2, 1, 2. This is where it would go after the flip, V prime. And then it's going to go 2 up and 1 left. So 1, 2, 1 left. So V double prime would be here, which is 4, 0, which is our option here. Now, if you were doing this on a digital, which you would be, this would be a great time to be using that dry erase marker on your screen rather than trying to I don't know how you do this on paper. I guess you'd have to sketch. The grid would take forever and it would be very highly inaccurate. This would be a great problem to use that sketch marker. Okay, so I identify. Okay, this is a composite. We're doing more than one, or it's a sequence of transformations, or a series, however it's going to be described. And it's interesting here. They don't use any of those terms. They just kind of hope you know what they're talking. Oh, it says 2 transformations, I guess. All right, number 32. Let's see what we got here. Two-parter. Okay. I'm going to try to zoom in a little bit because it's kind of small. Okay. 32. Circular cylinder W and some of its dimensions are shown in the diagram. What is the volume to the nearest cubic inch of cylinder W? All right, so the volume of a right circular cylinder is pi r squared h. So it's very similar to the circle form. I just added an h in there because there's a bunch of circles stacked on top of each other. So what is this to the nearest cubic inch? All right, so that means we're actually going to plug in for pi here, which is interesting. All right, so, and this is another problem where you'd want to do it on paper first before putting in here. All right, so pi, let's see, we're going to estimate here. R is going to be 6 because that's our radius, and the height's going to be 15. So we're going to get 36 times 15 times 3.14, which would roughly be roughly 1,000. Let's just do it out so you can see. Actually, it's probably better if I do it here. 3.14 times 36 times 15. So it's going to be this. We're going to round that to 1696. So 1,696 inches cubed, roughly. And that's with, because it's asking nearest cubic inch. It's not giving us the option of including pi as a symbol. All right, because it's actually more accurate to keep it in terms of pi. All right, part B. Zoom in a little bit. Let's move this in. There we go. The diagram shows circular cylinders X, Y, and Z, and the measures of their heights and radii. Compare the volumes of the three. All right. The volume of Y is blank to X. The volume of Z is blank to X. Okay, so Y and X. So these are actually going to have the same volume. You can tell because they have the same radius and the same height, and even though this is slanted, they would actually have the exact same volume. So that'd be same. Now Z compared to X. let's actually calculate both of them for this. So z is going to be pi r squared h, so pi 14 squared times 8, and then x is going to be pi r squared h, pi times 8 squared times 14. So they swap these around here. All right, so 14 squared for 96 times 8. So 1,568 pi. That's for z. That's the wide one here. And then the taller one here. So 8 squared is 64. 64 times 14. 896 pi. All right, so z is significantly larger than x. So z would be greater. Okay. All right, let's see number 33. So you can see we've had a few problems here, dimensional analysis problems, where you have to plug in some stuff into the formula. Oh, look at this one. I forgot about this one. This is a bit of a doozy. The compound inequality can be used to determine x, the approximate range in temperatures in degrees Fahrenheit, at which zinc is a liquid. Okay. What is the approximate range of temperatures in degrees Fahrenheit at which zinc is a liquid? All right, so we're going to basically solve this and statement, also known as a conjunction. So we're going to rewrite this. We're going to say, now you can round these, but we have a calculator, so we're going to be more accurate if we don't. So 419 5/10 is less than or equal to 5/9 times x minus 32. And then 5/9 x minus 32 is less than or equal to 907. Okay, so let's just do these. I'm going to zoom in more now so you can see this. And really we're just going to find these. So let's distribute this 5/9. So we have 419 and 5 is less than or equal to, so 5/9 x, and then 5 times 32 divided by 9, 17.8, around that. Actually, if I do that, it's going to be a little off, but that's okay. We'll still have a close enough to the answer. Minus 17.8. Okay, and then we're going to multiply by 9. This is where it's a little off. I should have multiplied by 9 here first, but that's okay, because I'm rounding here where I really don't want to, but that's okay. So we're going to multiply by 9 just to get rid of that. No, we'll get rid of this first. That's fine. Let's get rid of that constant. So we're going to add 17.8 to both sides. So 419 plus 17.8, 436.8 is less than or equal to 5/9 x. And now we're going to multiply both sides by 9/5. So 400, let's get rid of this. 436.8 times 9, and then divide by 5. 786.24. All right, so this is a little different than what it has in the options here because it's very, very close to 787.1. It's a little off because of me rounding this to 17.8, but that's to be expected. The way you could avoid that is if you multiply everything by 9 here, and then you're not going to, because it would get rid of this fraction, and it's, yeah. But anyway, this is close enough. And actually, you could actually stop here, because this is the minimum value, which is the only one that's close to this. So it's C, but let's just do the other side just so you can see what I'm talking about here. And in this case, I'm going to do what I mentioned before. I'm going to multiply everything by 9 just to get rid of that fraction. So this will become 5 times x minus 32. And let's multiply 907 by 9. Is it 8,163? And then we're going to distribute actually, we're going to distribute the 5. I should probably just divide by 5, whatever, that's fine. So we're going to get 5x minus 32 times 5. You could just multiply by the reciprocal there, but whatever. 32 times 5, 160. I'm going to add 160 both sides. So 8,163 plus 160, 8,223. Divide that by 5. So we get 1664.6. Okay, so you can see here, it's going to be between these two values. It's greater than or equal to this, and it's less than or equal to that, which is right here. But you only needed to find the first value, and that would have eliminated the other options. All right, we're going to stop the video there because we're over the 20-minute mark, and we'll do another one. Thanks, guys.